Okay, let me share the screen first. Can you see the screen?
Yes.
This board. Can you, can you see the board?
Yes.
Okay. So we were discussing that when we dissolve solid into liquid, we get a solution.
Yes.
Okay.
Yes.
And I was telling you about an example of which we have the solid as sugar and liquid as water, and it is making a soluble solution.
Yeah.
Okay. How about
Let me
if
just get the room.
what you said, Umayda? Hello. Can you hear me, Umayda?
Yeah, my sister keeps on putting loud music and distracting me. I'm trying to get out.
It's okay. I was telling you about the solution. Like solution is we dissolve one or two mixtures together and it form a solution. So the mixture is like
Yeah.
we are adding solid into liquid and it is forming a mixture which is if it is soluble then it is forming a solution. Okay, so
Yes.
this solid may be any sugar or water, it is forming a soluble solution. Soluble is one which is completely dissolved. Okay,
Yeah.
the insoluble is okay. Can you tell me any example of insoluble solution?
Uh, iron and water. Why is
Yeah,
my iPad closing? 1 second, miss. I can't see. My iPad just shut it down for some reason. It keeps on doing that. Yeah.
you cannot see the screen, Omaiza?
At first I couldn't. Now I can see.
Okay, that's good. So this is the example of soluble solution, and this is the insoluble solution example. The sand in water
Yeah.
is also the example of soluble or insoluble?
Insoluble.
Yeah, insoluble. So I was telling you that the solution is soluble when this has like the solid that we are going to dissolve has less intermolecular forces of attraction than that of liquid. If it has less attraction, then it is soluble. Otherwise, it is insoluble. Okay? Like this sand has more intermolecular forces of attraction than that of water. That's why it is insoluble. But this sugar, it has less intermolecular forces of attraction among its particles than that of water. That's why it is soluble.
Yeah.
Okay, is it clear now?
Yes.
It has less intermolecular forces than this water. That's why it is soluble. This sand has more intermolecular forces of attraction among its particles than that of water. Like the water has less intermolecular forces of attraction among its particles than
Oh,
that of sand. That's why.
so sand has more. That's why it's insoluble.
Yes, yes, this is the point that I want you to keep in your mind. Okay,
Okay.
the point is that whenever the particle has less intermolecular forces of attraction, it is going to be soluble. Otherwise, if it has more intermolecular forces of attraction like that of sand and iron, then it is insoluble.
Okay.
Is it clear now?
Yeah.
Sure.
Yeah.
So this was the point that we were discussing insolubility. Okay, this solubility is dependent on intermolecular forces of attraction. It will be among the solids or the liquids. If the solids has more intermolecular forces of attraction than that of liquid, then it is insoluble. If the solids has less intermolecular forces of attraction than
Oh,
liquid,
okay.
then it is soluble. Okay, it's clear now?
So if it has less, it's soluble. If it has more, it's insoluble.
Yes. Yes, Umayza, it's right. If it has more
Oh, yeah.
intermolecular forces of attraction among its particles, then it cannot be dissolved. It is insoluble. If it has less, it is soluble. Clear?
Okay, yeah.
And what about these particles? The metals have which property? I was telling you last time. Metal has which unique property?
Free electrons.
Yeah. So this free electron is helping metals to.
Be a good conductor to electricity and heat.
Very good. Yes. This free electrons helps in conductivity of metal. Okay.
Yes.
So this was about
Okay.
the properties. So now we are moving on towards the next thing, which is about, this is also, these all are the physical properties like solubility, the strength, like we can observe them. For solids and liquids and gases, we have some other properties as well. Okay, these are the melting, freezing, evaporating
So
properties.
solid to liquid is melting. Liquid to solid is freezing. Gas to liquid is condensation. Liquid to gas is evaporation. Gas to solid is condensation. And
So
solid to gas is sublimation.
this is not like this, like how you are explaining. It's not like in this way. Although you are right, but you have to tell me that how the solid is melting and forming into liquid. Like, can you tell me with any example?
Heating,
Okay, we are heating the
filling,
solid and it is converted
boiling,
into.
liquid.
Okay, so give me the example, like how.
Like you like
Okay,
hot water you can put on a solid and it can like
okay,
melt.
how the salt hot water is converted into solid.
Uh, hot water converted into solid. You can freeze it in the fridge
Yes,
or freezer
yes, and it will form.
and ice.
Yes. So this ice is the solid state.
Yeah.
Okay. So ice is solid. So do you know like at which temperature the water converts into ice?
No, I just put it in the freezer for me.
So the
Uh,
temperature in the freezer is 0 degrees. At 0 degree, the water,
so super cold.
yes, okay. So the water converts into solid, which we call ice. Okay. And when we are heating this ice, it's it starts melting.
Okay.
Okay. So when we are, this is the water. You can take example, this liquid is a water. Okay, liquid can be any, but here we are just taking water as an example. Okay, so this liquid is water and we are freezing it. When we are freezing it, it is converted into ice, that is in the form of solid.
Okay.
Okay, we just
Yeah.
we have water, we just freezed it in the refrigerator at 0 degrees and it has just converted into ice. So this is called freezing. We have given 0 degree temperature to it. Okay, and at which temperature
Okay.
the ice starts evaporating? Okay, first of all the ice start
Evaporated?
move. First of all the ice starts melting. Melting is like
Uh,
it is converted into liquid. Okay.
like when it's like not cold, like it's hot or warm, it just
Yes.
melts.
Yes, it's just normal water, normal temperature water, the room temperature water.
Yeah,
Okay.
room temperature starts to melt.
Yeah. So the water when is freezed is converted into solid form, which is ice. And if we like put the ice at room temperature, then it start melting. It again converts into liquid. Okay. So here you have one more thing. to keep in your mind that this reaction is the reversible reaction. Okay?
Okay.
This
Okay.
reaction, the water was first, like, you can convert water into ice and ice into water. So, like, the reaction is in both directions. So for this, most of the times we use this arrow, not this, but we use this type of arrow. Okay, Fatma, Umaiza? Uh,
Okay.
this type of arrow. This one in one direction, the other in the other direction. So this is used for the reversible reactions.
Okay.
And it means the reaction is in both directions. Okay? If you are converting water into ice, you can easily convert it back. Like you can convert ice back into water.
Yeah, we
Okay?
can.
So the reaction which is occurring in both the steps is known as the reversible reaction. However, the reaction that, like, if you have just added anything into water and it just solubilized, and we cannot take that back, so that is the irreversible reaction. Like you are just burning a paper. If
Yeah.
you
What else?
burning a paper, if you burn a paper, what happens? It converts
Turns
into
into gas.
what you just said about.
It doesn't turn into liquid. That's for
No,
sure.
no, 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 no. The burning of paper, it will give you what you say about
Ashes?
what you just said.
Ash? Like
Yes,
ash?
yes, 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 ash. But you cannot convert this ash back into the paper.
No, that's an irreversible change.
Yes. So from here you can have one more term to remember is the reversible and irreversible reactions. Okay, the reversibles are those that can be.
The reversible is like the one that can be reversed, like change like solid to liquid and liquid to solid, like freezing and melting.
Yes, like they are changed back into their original entity.
Yeah.
Okay, and the irreversibles are.
Irreversible is like burning paper, cooking, mixing other types of ingredients to make something. You can't
Yeah,
get this like baking a cake. You can't get the flour back after it's done.
yeah. Okay, so the melting is like we just converted ice into liquid, and if we heat it, heat this water at 100 degrees, this liquid, it will convert into steam.
Yes.
Okay, and this phenomena is known as evaporation. Okay,
Okay.
this is called evaporation. Like it starts steam, like the forming of steam is evaporation. Okay,
Oh.
the particles, like if you cover it with the lid, on the lid it is small tiny water droplets start forming. So this is called steam, and this process is known as evaporation. Okay, the liquid has converted into steam, into tiny water particles. Okay, is it clear? Omaiza, are you getting the point? I cannot hear you,
Okay.
Omaiza. Omaiza, are you there? I can't hear you.
Hello.
Um,
Oh,
I can't hear you,
hear
my.
me?
Your voice is clutching. It's like
Um.
glitching. It's now clear.
Oh, one
It
second.
it's clear now, Omaiza.
Miss, can you hear me now?
Yes,
Hello.
it's clear. Yes, I
Okay.
can hear you. I can hear you, Maiza.
Thank you. Okay.
Okay. So we were discussing about the thing that this liquid. Okay, so I was telling you about that if we heat water at 100, you can hear, Omaza? Are you listening?
Yeah, I can hear you now.
Okay,
Yeah.
that's good. So I was telling you that if this water is heated at 100 degrees, what happens? The steam is formed, tiny water particles.
Yes, I can't see your screen.
You can't see. Okay, let me check. How about now?
Yeah, now I can.
Okay. So I was telling you that if you heat this water at 100 degrees, what happens? Steam is formed.
Yeah.
Okay, it is like tiny water particles. They just start gathering on the lid. Okay, like if we have a pot
Okay.
and we cover it with lid, what happens beneath it? The tiny droplets start forming. Uh, have you ever cooked anything?
Yeah, French fries.
So if you, but in the French fries, you are not covering the pot with the lid. In some of the recipes, it's like when you cover the pot with the lid, sometimes the steam start forming.
Yeah.
So have you ever observed it?
Yeah, when my mom was making something, I don't know.
So that is the steam. Okay. So this steam is formed when you are heating the liquid. Once you switch off this stove, what happens? The steam, it will then come back into the pot, which is like, this process is known as condensation. Okay, the tiny droplets that are
Oh,
formed on the lid, they will then fall into the pot. So this process is known as condensation. Okay, those tiny water particles, they are just coming back into the pot. So this process is condensation. जाओ बेटा आइसक्रीम खाओ जाओ. Okay, is it clear? Ab- Umayza, about condensation, have
yeah.
you?
Yes.
Okay.
How will condensation go from solid to gas?
Uh, Condensation is basically the tiny gas particles when they come back into their original state. That is condensation. Okay.
Okay.
Condensing, which is like the tiny water particles, they are coming back into the liquid pot. They are condensing.
Yeah.
Evaporating is like, it is actually when we have no heat. We are not giving the heat. The evaporation, it happens with heat. Okay. Are you getting the
Okay.
point, Umayza? The
Yes.
evaporation is related to heat. We are heating the liquid, and the particles, the water particles, they just move upward, and we call them steam. And this process
How,
in which the steam is
how will
forming is known as evaporation.
how will we do gas to solid
We are
or
not
like solid, or is
like,
it not like
yes, like the gas particles, they are coming back into their original form, which if they are in the steam form and they are coming back into the liquid form, this is also condensation. When the gas particles, they are coming back into their solid form, this actually happens like the solid. Let me show you. Like we have a solid, okay, and if this solid, like most of the times what happens, solid firstly converts into liquid and then goes into the gaseous state. Okay.
oh,
Any solid, it first melts. into liquid. But we have another phenomena as well in which the solid directly goes into gaseous state, and we call this process as sublimation. Okay, this
Okay.
sublimation is a process in which solid, without going into liquid state, directly goes into gaseous state. Okay, you have to just keep this thing in your mind, that solid directly goes into gaseous state.
Okay.
Okay, if solid directly goes into gaseous state, we call this sublimation.
Sublimation. And
Okay,
what's solidification? What's solidification?
what you just said, solid.
Solidification. I don't know. My teacher said it in school.
Liquefaction.
No, solidification.
Just give me the
Wait, let me search if it's actual thing first.
spelling of this. I'm not getting the word you're pronouncing. Solid duplication,
Solidification.
defecation,
So solidification. Solidification.
effication,
Yeah.
EFFI. So,
Yes. No. Let me write in chat.
I haven't heard about this word. Like,
This word.
let me check. Solidification. Okay, okay. It is like solidifying. We have a liquid. Okay. Any liquid which is like thick liquid, like wax. Have you ever seen
Oh,
wax?
wax and like honey. Yeah.
Yes. So when temperature becomes low, which is like in winters, it it solidifies. Okay, we are not.
Oh, so on its own.
Yeah,
It, so wax it becomes hard on its own.
yeah. So we are not saying that now it is a solid, but we say that this is the solid-like thing. That is why we say solidification. Like it solidifies, but it is not a solid.
Okay.
Okay, we are just
Okay.
exemplifying it like that. It
Okay.
solidifies or solidification. Solidification is not for solids. It's for like solid type things. This wax, when it becomes hard, we say that it solidifies. Okay.
Okay. Miss, why are you recording the meeting?
Uh, for my own
Okay.
points that I want to save them in my own computer.
Oh, okay.
So we were discussing about some processes. So the first one is about sublimation. Okay, sublimation is which process? Just tell me what happens in sublimation.
Sublimation is the solid to liquid to gas.
No,
What? You just said that though.
no. I said that
Liquid to
sublimation
gas?
is a just
Solid to
now.
gas.
Yes, solid without going into liquid phase directly goes into the gaseous phase. Okay, when the
Oh,
solid converts into gaseous state, we call this process as sublimation. Okay, solid is
okay.
going directly into gaseous state. Okay,
Okay.
sublimation is like solid goes into gaseous, solid to gas. And when solid goes into liquid, we call this process as melting. Okay.
Okay.
One is sublimation, in which solid directly goes into the gaseous state. The other one is melting, in which the solid goes into liquid, and we call this process as melting. Okay.
Okay.
And sometimes what happens, the solid when goes into liquid, after some time it solidifies in the form of crystal, and we call this process as crystallization. Maybe this is not in your syllabus. You have sublimation, melting.
What's crystal? Crystallization?
Yes, that is crystallization. It's like the tiny crystals are formed, which is like if you observe the salt is crystalline state, tiny crystals.
Yeah, I've heard of it.
Yes, so that process is crystallization. That is how the salt is formed, through crystallization. Okay.
Okay.
Sublimation, melting. Okay. The third one was the fourth is freezing. Like we just decreased the temperature. Okay. We have a liquid and we decrease the temperature and it freezes. And we call this as freezing. Okay. Are you getting the idea of these points? What is melting? What is
Yeah.
freezing? What is sublimation?
So, Miss, what's the process if you're like cooking frozen food like nuggets? Like first you get it out of your freezer, then you just cook them, and then they turn hot.
So it's
Or
like,
they're just eating.
first of all, they are frozen and
Yeah.
they then become defrost. We are just defrosting them.
Oh.
Okay. And then we are frying them. So there are the two processes that are in making nuggets. Okay. First
Okay.
of all, defrost. Def, uh, we are defrosting it and then we are just frying it. So that is not related to our topic. Our topic is related to these processes: melting, sublimation, condensation. Condensation is like the gas particles. They are, if they are made,
And
they may be, yeah,
evaporation.
yes, they are coming back to their original state, which is like they may be going back to their solid state or going back to their liquid state. Okay. This is
Okay.
condensation. So the most important is the sublimation. You must know what is sublimation. Just because the others are very easy. What is sublimation?
Oh, how come?
I'm just asking you to tell me what is
Yeah, my
sublimation.
mouth is burning. Anyway,
What happened?
my mouth is burning. Sublimation is solid to gas.
Yes, solid is going directly to gaseous state. Okay.
Yeah.
Okay. The other most important topic in this physical changes unit was about this scientific method. Have you have like discussed this thing in your school?
What? No.
The observation hypothesis theory.
Oh, that. Yeah.
So can you tell me how we are making any theory or law? Like there is a whole
With the
process.
investigation,
Yes.
before we do make a theory or a law, we have to do the investigation.
Yes. And all of this investigation needs, what does it need?
Um,
Like
the
before,
aim dash question. The prediction, fair test, method, conclusion,
Good. And like
material, bias.
you must need the aim, you must need the objective, you must need the observations. Okay. And
Okay.
all of these things, they are collectively known as the
Process of investigation.
this whole thing is known as scientific method.
Same thing.
Okay.
Okay.
This whole thing is scientific method. It is like we have observations first, then comes the hypothesis,
Okay.
then we are formulating the like we are formulating the hypothesis. So for that we need some experiments, and after
Yeah.
experimentation we make like a data of that experiment,
Yeah.
and
And
out of
then
data we make a theory,
you
and
need
that
the material
what you just said, Umayza?
materials.
Yes, in data we need we make all those materials, like we just put them and we formulate them,
No, you
and
have to write which materials you're using.
yes, we will write materials in data,
Oh,
like this type of materials we use, and all of this comes in data. Okay.
you need a conclusion.
Yes, then we have the conclusion. Out of those conclusions we make the theory, and like that theory is formulating again and again, and that then becomes the
For
law.
what? Yeah.
Okay.
Law or law?
Law. Like we have the maybe you have Mendel's law of segregation. Maybe you have heard this in bio.
No.
Okay. So
Wait,
all the
who's law?
law, Mendel's law of segregation, law, like,
Mendel? No. I've heard of the one that put meat in a jar and saw and opened the jar and then see if which one would the flies come to.
and what about the light traveling in the straight line? One of the scientists have performed different experiments to check whether the light is traveling in a straight line or not. So he made different
We studied
experiments.
about that in first grade, but then we never found out the scientist. Probably because it
Oh,
was in the first grade.
okay, but that was just the example how the scientific method is made. So first of all, just made the observation. Like if you see the bulb, you cannot assume that the light is traveling in a straight line or not, just because the light has just spread in the whole room.
Yeah, I guess.
So the observation was whether it is traveling in a straight line or is it moving in a whole room. So this was the observation. So the
Or
hypothesis was carried out by experimentation. Like hypothesis was done. It is moving straight line or is it moving in haphazard? So this was like we have the background knowledge and we are just constructing a hypothesis. Okay, hypothesis is like we
okay,
are just imagining things. Okay, we have the observations, but we are just making the data on our own imagination. We are not making any experimental data out of it.
okay,
So we are then formulating that hypothesis. That is when we are making the experiments. Okay, first of all we have
okay,
the observations, then we are making the hypothesis out of it. uh, After that hypothesis, like we in hypothesis we are just making the imaginary data.
what? Imaginary data?
Yes, like we have the We have the observation. Just keep this thing in your mind that you have the observation, whether the light is traveling in a straight line or is it moving in not in a straight line. Okay, you
It's
have a
not.
bulb, you have the bulb in your room, the light is just spread out in the whole room, but you are
Yeah,
thinking that is it moving in straight line or not. Okay,
it's
so
not.
the imaginary data that you have made in your mind is the hypothesis.
Oh,
Okay, but then you are making the experiments to check whether it is moving in a straight line or not. Okay, for different experiments we use different types of things, but for this we only need a light, like you can use the torch light. Okay, for
okay.
experiments you need a light, and you have a lamp, or you can say that it is a vase.
A what?
Lamp or a vase. Okay, lamp.
Oh,
Our timing is also running, but I'll just show you quickly. Okay, we have a light and we have a lamp. Okay, this is in this lamp there's no light. Okay, this is only, you can say that this is an object
okay.
placed in front of the light. Okay, we are just making the experiments whether the light is traveling in straight line or not. Okay, when this object is placed in the path of light, what happens? From where there is no like here it has the body, where it has the body the light is not going, but
Um,
from the other side the light is passing. Are you getting the idea? It's like the
yeah,
shadow of this object forms. When the light hits this object, what happens? The shadow of this object forms, which means that
yeah.
light is traveling in a straight line. That's why when it hit
Oh,
that this object, yes, light travels in a straight line.
oh, why?
This is the experiment. Like when this light hit the object, it cast a shadow. It's not like it just went straight out of its body.
Yeah,
Okay,
okay.
so this is how the experiment was done. And then different data, like different lights were then fall on different objects, and we have made a data out of it. Then we made the conclusions that yes, when any object is placed in the path of light, what happens? It casts a shadow instead of passing out of its body.
Yeah.
So this is how the scientific method is used to make different laws. This is a normal example for